Ever wondered why some AI systems ace standardized tests, but struggle with real-world complexity? Today, we're diving into a groundbreaking study that's redefining how we measure AI success, especially when it comes to navigating the tangled, high-stakes challenges of the real world. Let's break it down. AI models, from those powering climate simulations to your smart speaker's voice recognition, are typically evaluated using benchmarks, structured datasets designed to test specific skills. But here's the critical question. What if these benchmarks are more like practice exams than real-life scenarios? This research tackles that very issue, and the findings could reshape how we train and assess AI. The study focused on environmental regulatory documents, massive, interdisciplinary texts that blend scientific data, legal language, and policy frameworks. These aren't just dense, they're intentionally ambiguous. For example, a query for local wildlife might miss faunal ecosystems or biodiversity hotspots because traditional AI models rely on keyword matching, not contextual understanding. It's like trying to solve a 3D puzzle with only 2D pieces. To address this, researchers fine-tuned a model called CallBird EV2 using thousands of these regulatory documents. But here's the key twist. They tested it on two distinct benchmarks. One was a clean, structured dataset. Think of it as a meticulously organized library. The other was a chaotic, overlapping dataset mimicking the real-world mess of policy language, where terms bleed into one another and context is everything. The results? A stark contrast. On the clean benchmark, the model's performance improved by a mere 0.6%. But on the messy, real-world test, the same adjustment boosted accuracy by 22%, a 3.6x improvement. Why the gap? The researchers analyzed metrics like cosine distance, a measure of semantic similarity between text fragments, and silhouette scores, which quantify how well clusters of data align. They found that the chaotic benchmark forced the model to refine its ability to detect nuanced relationships, uncovering strengths it hadn't shown in controlled environments. This has huge implications. Imagine training a driver on a perfectly paved track versus a rain-slicked city street with unpredictable traffic. The real-world test reveals true capability. In fields like environmental policy, where misinterpretations could lead to ecological harm or legal missteps, this matters deeply. If we only test AI in sanitized environments, we risk overlooking its potential to handle the complexity of actual problems. The takeaway: evaluation methods don't just measure progress, they define it. To build AI that thrives in real-world scenarios, we need benchmarks that mirror the messiness of reality. Otherwise, we're not testing whether AI can solve problems, we're just checking if it can pass a test. Thanks for watching. If you're curious about how AI is shaping the future, hit subscribe. And drop a comment. What's a real-world problem you think AI needs to master next? Until next time.